Welcome. Let's look at two difficult topics in this video. Those topics are the correlation coefficient and the coefficient of determination. You can find these topics in the analytical techniques of budgeting in your performance management syllabus. Now, I have an extract from our study hub open on my screen here. The reason that this topic is difficult is because of this scary looking formula. Let's do three things in this video. One, let's demystify this topic, correlation coefficient. Two, let's practice using this formula. And then three, we'll look at the coefficient of determination. To make sense of correlation, let's look at an example. Let's imagine I have a business manufacturing and selling handmade wooden bowls. The process of making a wooden bowl is labor intensive, and every time that I sell a bowl, I pay a $10 commission to the salesman. I've gathered some data from last year. I've got my months. And I've got the total units produced in each month. And we can see that it varies something between 85 and 121. So we have variable sales. Now, here's that commission that I give to the salesperson, $10 commission. Right away, I can see that that's correlating as a variable cost, isn't it? And we also have a column for the labor hours, the total time it took to produce the number of units in that given month. Let's go back to the commission cost. And if I arrange my data in ascending order, we got units, and then we have a corresponding cost. So let's just review labeling the axes. The units here, that would be the x-axis, the independent variable. I decide how many units I make. And the y variable, in this case, that total cost, that's the dependent variable. That's the variable that changes as a result of changing the x-axis, the dependent variable. And look at this. We see that there is a relationship between the units and the cost. That is the idea of correlation. When one variable changes, how much change is there in the second variable? And in this situation, we see positive correlation because as the units increase, the cost increases as well. And we can also describe this as a perfect positive correlation because this line is straight. The commission cost is purely variable. So 85 means 850, 121, or 120 is 1200. So that's perfect positive correlation. If the line were sloping downwards, that would be negative correlation. And I'll show you that shortly. If we look at the labor time, well, we can also observe there is a general upward sloping line. So we would describe that as positive correlation, but it is not perfect correlation. The line is not straight. So what's happening here? Well, labor time, let's imagine we have two factors there. The skills of the worker. More experienced workers go faster, less experienced workers go slower, and the quality of the wood. If I have high quality wood, the team can produce the bowls faster. If I have poor quality wood with lots of knots or maybe split wood, then it takes longer to make the bowls. So right here, if I look at my production data in more detail, oh, this is a month that I happen to have mostly inexperienced new workers. And they were also working with the bad batch of wood. Oh, look, in this month, we had our most experienced team ever, and we had a great batch of wood. So there are more factors at play than just the number of units. I'd like to describe the correlation between units and hours with a number. I'd like to quantify that relationship, and that's where that correlation coefficient formula comes in. That R value describes the relationship between the change in the units and the change in the hours. Here's that formula again. To calculate the R, the correlation coefficient, we need some data, and then we need to perform some calculations. N, number of rows in our data set, okay? Number of observations we have. The capital sigma, that stands for sum. So we need the sum of x times y minus the sum of x multiplied by the sum of y. In the denominator, we also need that n value, but we'll need to calculate the sum of different variables in some cases. Let's look at this with data. It will make more sense. Let's look at activity 7 together from the study hub. And let's read the little story. The company Cutters, they use a machine which can be operated at different speeds. The machine is continuously operated without stopping. The production manager has collected the following data for the life of a component before it wears out at different machine speeds. So we have two columns. Revolutions per second, the speed at which the machine rotates, the blade or the motor rotates. And then we have, that's the independent variable. We choose the machine revolution speed. Then we have the life of the machine. But look at this, the life of the component. The faster the blade spins, the faster the component wears out. So we're observing negative correlation here. And what do we need to do? Calculate the correlation coefficient and comment on our results. Let's tackle this requirement in the spreadsheet because there are a lot of calculations to do. I've got the numbers reproduced. We've got the machine speed and we've got the life, okay, the two columns. Machine speed is X, life is Y. And first thing we need to do is get the number of observations, okay? So we count up the number of rows. We can very quickly do that in Excel with the count function. So I grab that and we should see that there are 10 rows. Now we need to get the sum of x squared and the sum of y squared. So we can use the sum function. That's equal to the sum of those figures. Copy, paste. So we've got the sum of x, we've got the sum of y. And all we have to do is grab that number and raise it with the caret symbol to the power of 2. And there we have the sum of x squared. And we can do the same thing over here, the sum of y. Next step is to get the product of x and y in the next column. So all we have to do is multiply one by the other. And we add those up. And that will be equal to the sum function. Grab that again right there. And we can copy that over. I think I did that already when I practiced. Now copy over. And now we have x squared. So I'm going to get x squared over here. Raise that item to the power of 2. And y squared is over here, the power of 2. And we've completed the table. We now have all the data we need for calculating the correlation coefficient. Before we go further, let's now take apart this formula. We need to find n. N, number of rows. That would be 10. We need the sum of xy. That's down here. Minus the sum of x multiplied by the sum of y. That would be here. The sum of x multiplied by the sum of y. That's the numerator. Now, in the denominator, we need n again. We found n over here. We need the sum of x squared, which is over here. And the trickiest part of the formula, and this is often one of the distractors in a multiple choice question, when they put the sum of x in the brackets, that means we need to take this one, sum of x over here squared. So that, the sum of x squared, is different than this one here. So to recap, we've got to find n. That's the 10. The sum of x squared. X squared, the sum. Now, I've got to get over here, x squared to the power of 2. That would be this one. X squared to the power of 2. And n, that's the 10. The sum of y squared over here. And then we get the sum of y, again, which is right here. And we raise that to the power of 2. I've shown you how to calculate all the variables. I've shown you now how to plug the variables into the formula. Let's look at the formula with those figures inserted into the correct places. At this point, might be a good idea, pause the video and retrace the figures from the spreadsheet into the equation. Make sure you understand where each of those figures comes from, and make sure you understand the difference between x squared to the power of 2, that's the x squared in the brackets raised to the power of 2, versus the sum of x squared, which is that column above, that's column R. Now that you understand how to calculate the variables, how to plug them into the formula, it's time to practice doing the calculation. And you have to be very careful here to preserve the order of operation. So you got to do the items that are in the brackets first. So you got to get the numerator, and then you've got to get that denominator. And don't forget to find the square root when you're all done in the denominator. So go ahead, get out your scientific calculator and try this calculation. I recommend you do the numerator and the denominator as separate calculations, and then after that you can get the final result. For the numerator, I get negative 2,265. For the denominator, I get 2,381.9. So we confirm that it is negative correlation, and the final result is a negative 0.95. Practice this calculation a couple of times. Make sure you can get that negative 0.995 quickly and accurately.